Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1. Would like to present about group project of cost-effective solution in utilization electrical energy system. My name Amirul Hazim bin Azman. I would like to present about the introduction. At first, global energy demand continue to rise increase and to need for energy efficiency. Okay, next, environmental concerns are pushing Malaysia to act through the 12 Malaysia Plan, focusing on carbon reduction and renewable energy. This project support those goals by evaluating energy use in existing building instead of starting from scratch. Next, we analyze the current electrical system to identify inefficiency and propose practical improvement. Next, the approach is based on a knowledge from subject utilization of electrical energy. We also participate in a visit and industry sharing season with MPK engineer. The experience highlight the importance of energy regulation, applied technologies, and engineer role in sustainability. This project combines classroom learning and real-world insight to reduce energy waste and support. Okay, next I will present about company background. Okay, my company group is Elexian Wiring Expert. Okay, Elexian Wiring Expert is a student lead team from Faculty of Electrical and Electronic Engineering in UTHM. Our vision is to improve energy use in building through smart and affordable electrical solution. We focus on upgrade all wiring system, improve energy efficiency, and promoting the use of renewable energy. By community sustainable practice with smart technology, we aim to reduce carbon emission and support a greener future. Our goal is to create better electrical system that benefit both people and the environment. Okay, next slide is. Next, I will present about our team for this project. Okay, at first, this is me, Amirul Hazim, our group leader. Okay, next is Iskwan, our secretary leader, and then Devika is the research engineer, and then Amjad is the design engineer, and Hafizuddin is our financial analysis. Each of us has our own role, and we work together to make this project successful. I will present about structured team. At first is me, Amirul Hazim bin Azman, as a group leader for this project. My responsibility is lead project and meeting. Okay, next is Aku Amirul Mukmin bin Jeffrey as a secretary leader. The responsibility is record all work and settle documentation. Okay, next is Muhammad Amjad Mirozan is as a design engineer. The responsibility is handle schematic drawing and technical design project. Okay, next Muhammad Hafizuddin bin Novir Rashwandi. The role is financial analysis. The responsibility is manage load and calculation and calculate the cost for this project. And last is Devika, anak perempuan Sivananta. The role is research engineer. The responsibility is research green solution and compliance. For me presented is motto and vision. Okay, in my company we have motto. The motto is wired for safety, built for reliability. And the vision is we aim to be the trusted name in wiring and electrical work known for delivering safe, smart and reliability solution that power up homes, business and communities with confidence and care.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ikwan Amrul Mujibri and my number is CA240156. So I will continue my group presentation with the summary of industrial sharing session and also for the site visit. So during the industrial talk, where the speaker from KRPJ share the insight into how electrical projects are planned. So we also they explain also the role of consultant, contractor and also for the M&E engineer, where they emphasize the importance of the complying with the Malaysian standard MS. So we also learn about the low voltage LV and also for the extra low voltage. So this session highlight how modern infrastructure incorporate sustainable system supporting the 12 Malaysian Plan, which is 12 MP. So therefore, for the site visit to MPK, which is Majlis Perbandaran Keluang, we observe the real world application of electrical system in municipal infrastructure, where we saw the component like the main switchboard, the transformer, the vacuum circuit breaker, and also the backup generator lah. So this visit also introduced us to the HVAC system, which using the variable refrigerator flow (VRF), which is energy efficient and suitable for modern building. So while we tour into the control room, we also saw the KNX automation technology, which is used to manage the lighting and also for the air condition and for the ventilation system. So overall, for this both activity actually help us connect theory with practice, which we gain a deeper understanding in areas such as project coordination, power distribution, automation, and also for the energy efficient system. So that's all for me. Thank you. Bismillahirrahmanirrahim. So I will continue for my project objective. So for the first objective, actually to evaluate and retrofit an accessible thing by redesign its electrical and mechanical system with the aim of improving the energy efficient function and also the environmental performance. So for the objective number 2 is to align the building redesign with the principle of the 12 Malaysian Plan, which is 12 MP, focusing on low carbon development, energy saving strategies, and also sustainable energy practice. So for the objective number 3 is to apply practical knowledge gained from the industrial sharing session and site visit, specifically integrating real municipal design standard and compliance strategy into the proposed solution. So for the objective number 4 is to incorporate relevant code, standard and municipal requirement such as Malaysian Standard MS to ensure the retrofit plan meet current safety, performance and sustainable criteria. So for the point number 5, for the objective is to act as a consultant by proposing innovative, cost-effective and practical engineering solution by helping demonstrate how technical knowledge and industrial exposure can be applied to solve real-world infrastructure challenge. That's all for me. Thank you.
Okay, so this is a flowchart of the project. First, we draw the floor plan for the proposed location. Second, we draw the schematic diagram for the electrical appliance. Next, we calculate the total power consumption. Next, we find improvement of energy efficiency. Then we calculate the total power consumption and light illuminance. Then we compare before and after. If we satisfied with the power consumption, we redraw the new floor plan with energy and also schematic diagram. Last one, we analyze and we do the discussion of the project.
Okay, next I will continue the presentation for floor plan before improvement. So this is the floor plan, existing floor plan of Surau Taman University Parit Raja that I draw it using AutoCAD software. The layout show where all light, fan and electrical point were installed. At this stage, we identify some dim area, especially in the back corner and corridor. Also at the main hall prayer. This happened because the light not enough lumen, so we need to improve the light. Okay, next I will continue with electrical schematic before the improvement. This is the schematic diagram before we do the improvement. It shows the wiring layout and how electrical appliances were connected. The diagram helps us to detect issue of overpower consumption happen in this circuit. So as we can see, the total connected load show a high value because have many old electric appliances that are connected. Okay, next I will continue with the load calculation before improvement. So we can calculate the total power load based on the existing equipment. There were 30 unit downlight of 60 watt and 30 unit of fluorescent pentafloor light of 36 watt, 9 unit of ceiling fan 90 watt, 30 unit wall fan 75 watt, 7 air conditioner of 1 horsepower and 14 socket of 13 ampere. The maximum demand was around 6,568.67, which was very high considering the lighting quality and cooling effect. Next, I continue with calculation for illumination before improvement. So before the upgrade, we had about 107.9k lumens from the fluorescent light, but this was not enough because the brightness was not spread evenly. Many areas were still dark, especially at night or during cloudy days. Okay, next. This is the floor plan after the improvement. So, this is the new floor plan after improvement. The layout was redesigned to give better lighting coverage. I also rearranged the lighting point to get balanced bright and more efficient use of appliance, reduce unnecessary fixture, and focus on lighting the previously dim area. The result was a more balanced and brighter environment. Okay. Next, I will continue this presentation for electrical schematic after improvement. Here is the update electrical schematic. The new system include better separation of circuit, especially for high power equipment like aircon. I divided to two size power rating, which is 2 unit of 1 horsepower and 3 unit for 1.5 horsepower. Next, I increase the light, but it will use low wattage and also have high value of lumen, which is 100% LED. The wiring is now safer, more organized, and easier to maintain in the future. Okay. Next, for load calculation after improvement, we do the upgrade. We use energy efficient appliance. Downlight LED were reduced to 4 unit, 12 watt. We use 46 panel floor, LED light, 27 watt, and replace the fan with brushless type. Air conditioner were changed to 2 unit of 1 HP and 3 unit of 1.5 HP. The maximum demand reduced to 4,923.77. I also calculate for after improvement. So after the upgrade, we use 46 Pendaflow LED light and downlight LED that gave around 118.84k lumens. Even though power usage decreased because it just used low wattage to bright some area, the lighting improved. This show that we use the right placement and efficient features. We can get better result using less energy. I think that's all from me. I will pass this presentation to the next presenter.
Greetings to our lecturer. I'm Devika and I'll be presenting the analysis and discussion of our project. This project was carried out at Surau Taman U to reduce electricity usage and improve energy management. We began by analyzing the original floor plan and single line diagram to understand the current electrical system. The Surau used outdated equipment like fluorescent lights, old fans, and multiple air conditioners, resulting in high power demand of around 9.22 kilowatts. To improve this, a new design was created using AutoCAD. Energy efficient LED lights replaced the old ones, reducing lighting power for 2184 watt to 1290 watts. Fans were upgraded to low power brushless models, dropping fan consumption from 1785 watt to just 550 watts. The air conditioning system was also optimized with fewer but more effective units. Overall, the total load dropped to 6.72 kilowatts, a 27% reduction. Despite using more lights, brightness actually increased from 37,500 lumens to 39,600 lumens thanks to efficient LEDs. In short, the upgraded system is safer, brighter, and much more energy efficient, leading to a long term savings and improved comfort at the surau.
Okay, lastly, I would like to present about the conclusion. This project allows our team at Election Wiring Expert to apply classroom knowledge in a real-world setting. By working on Surau Taman University Pari Raja, we identify issues like outdated lighting and energy waste. We propose solutions such as LED upgrades, battery layout, and sustainability future natural lighting. Site visit with KPRJ and MPK give us industry insight and highlight the engineer role in building efficiency infrastructure. Okay, lastly, overall this project shows us how engineering can make a real impact on the community and the environment. That's all from our group. Thank you.